Hi everyone, this is Bipin Kumar, founder of RPM Tutorials. Welcome to my channel. Today I am going to talk about defects of vision. There are three types of defects in the vision predominantly. First is myopia, which is nearsightedness, hypermetropia, which is farsightedness, and presbyopia, which has both problems. Okay, presbyopia usually happens with people with older age where eye muscles become weak. But these two, myopia and hypermetropia, these are common in any age group. Okay. Before we go forward about understanding how these problems happen in the eye, let's recollect a bit of understanding which we had regarding lenses. We know that convex lens is a converging lens. The focal length of convex lens is positive and therefore power of that lens is also positive. Whereas concave lens is a diverging lens. The focal length of that is negative and therefore power is also negative. Now let's look at the problem of myopia. Myopia is nearsightedness, where the objects which are near to the eye are clearly visible to the individual, but the objects which are at far distance from the eye is not clearly visible by the individual. Let's look at the normal eye. If suppose my eye is perfectly normal, then whatever objects are there at distance, that also I can see clearly. Now, the object at distance are considered to be at infinity, and therefore the rays coming out of those objects are supposed to come parallel to the principal axis. When they are coming to parallel to the principal axis, once they enter into the lens of the eye, they converge on the focus, and which is at the retina, and therefore we are able to see the object. So that's the situation of a normal eye, that the far distant object, rays coming from infinity parallel to the principal axis, they converge on the focus, which is at the retina, and therefore we are able to see the object at retina, and hence the communication happens to the brain, and then we are able to visualize the object. What happens for a myopic eye? For a myopic eye, the far point, the point at which, the distance at which our eye can see clearly, that come a bit closer than the infinite distance. It means, for example, at this point, the individual will be able to see clearly the far objects. But when the objects are farther than this, the individual will have blurred vision or will not be able to see properly. So, the far point has come a bit closer than infinity. And now, the rays coming out of this enter into the lens of the eye, and they converge on the retina, and therefore the individual is able to see the object up to this distance. The objects which are at farther distance than this, they are considered to be at infinite distance, and therefore the rays are coming parallel. But because of the myopic eye, the lens of the eye is converging these rays prior to the retina, earlier than the retina, and therefore the object formation is happening here, not at the retina, and therefore the individual is not able to see this object. Usually this problem happens if there is more curvature introduced in the lens of the eye, or the elongation of this part of the eye happens. Therefore, the convergence happens prior to the retina. Now, how to correct that? Now, we know that the convergence of all the rays are happening prior to the retina. So, our objective should be that the convergence should happen a bit further away from this point. So, to let that happen, we introduce a diverging lens as a corrective mechanism. So, now the rays coming which are parallel, they get a bit diverged first, and then they hit the eye and the lens of the eye, and then the lens of the eye is able to converge them onto the retina, and therefore these objects, the far objects also can be seen by the individual. So the corrective mechanism here is that putting a diverging lens, that is a concave lens, in front of the eye, and then those objects can be, the object formation can happen at the retina, and we can see those far objects also. So in case of myopic eye, the concave lens is the corrective lens. Now we know that the concave lens has focal length negative, therefore this power of the lens will be negative. Okay. Now let's consider the case of hypermetropia. Hypermetropia is also called farsightedness. That is, the distant objects can be easily seen, but the problem is there in seeing the near objects. Now let's look at a normal eye. For normal eye, the near vision is roughly around 25 centimeters. So you put a book in front of you 25 centimeters away, you should be able to easily read that. So this is a normal eye, that you are putting some object or book or something 25 centimeters away from the eye, and on the retina the object formation happens and you are able to read properly. Let's look at the hypermetropic eye. What happens is that the near point moves a bit further, okay, not on 25 centimeter, rather a bit more. So then object kept here you can read properly. So those people who have this kind of problem, they will move the book a bit further and then they are able to read properly, right? You can see easily that the rays coming out from here, they enter into the lens of the eye and they get converged at the retina. But if the same book is kept at the distance of the normal near point vision, that is 25 centimeter, the rays coming out of here will enter into the lens of the eye, and then their convergence will not happen onto the retina, rather it will go beyond the retina and the convergence happens here. Now because the convergence is not happening at the retina, therefore that object will not be seen. If it is a book, that book will not be comfortably read. Okay, there will be a blurred vision. Okay, why that happens? That happens if there is a shrinkage in this part of the eye, or the eye lens kind of, and the eye itself, the curvature increases, right? So then this kind of problem happens. Now what is the correction? Now we want that this convergence should happen at the retina. So we have to bring this convergence point nearer. So to bring that convergence point nearer, we put a converging lens. So when these rays are coming to this converging lens, which is put just outside the eye, then a bit of convergence already happens. So this is the normal direction of the rays. There is a bit of convergence already happened. And when these rays enter into the lens of the eye, then they converge at the retina. So earlier it was converging here, now the convergence happens a bit earlier at the retina, and then we are able to see the objects even put here at maybe 25 centimeter of distance, right? So correction for the hypermetropic eye is a convex lens, and convex lens focal length is positive, therefore power is positive. You might have heard that I have got a negative power or I have got a positive power. This is all related with what kind of error has happened, the defects has happened in the eye, and then what is the corrective lens which is being used. Okay? In a presbyopic eye, both these problems happen. So if both these problems of myopia and hypermetropia is appearing, then you will have to put a lens which has both characteristic. The same lens, in one part it will have convex lens, in another part it will have concave lens, so that it caters to both kind of defects. Okay. So by now you might have understood that how the problems happen in the eye and what kind of corrective lenses are used, why the power is positive, why the power is negative, and how these defect corrections happen. I'm sure you have that clarity now, and if any problem related with this kind of topic comes, you should be able to answer that properly. Thank you.